This is Unscripted Coding, and today we have yet another exciting project for you today. I have here, physically in front of me, a DigiSpark USB development board. It's tiny package and really tiny, and we'll open it in a moment. But it is basically this thing that you see on the screen right here. It is a tiny development board, which is similar to an Arduino. It uses a different chip called Tiny85, but it is functionally very, very similar. We're going to be using the Arduino IDE to build something, but the real inspiration here is a video that I did a while back where we were building a mouse jiggler. The code is available right on my GitHub, but really simply all we did was take one of these Arduino Pro Micro, and if you plug it into a computer, it's going to pretend it's a mouse, and it's just going to move that mouse. Now, we can imagine all sorts of reasons why you want to use this. You're at work, working from home, you want to keep your computer alive, keep yourself alive. A mouse jiggler is good for that. It might be really useful if you want to keep your screensaver from kicking in, from your computer sleeping. I sometimes use this at night when I run something and I want to make sure my computer is running. Now, one of the big problems I have trying to show this to my friends is that, yes, the Pro Micro is a tiny Arduino board. The Tiny85, the DigiSpark, is actually smaller. I'll show you a comparison later, but it's already quite tiny. It's size of, half my thumb, but it doesn't plug into USB. You gotta get a bulky USB cable, and for me, I chose, a pretty bulky one, and it adds to the footprint to it. Not a huge deal, but if we compare it to the DigiSpark, it is quite significant difference in size and convenience in having it around. So having this sit on my desk for a while has been annoying. It's just out of place, even though, I don't know if you can see, but my desk is a mess as is. What I wanted to mention is that there are so many different Arduino boards right now, and they do serve different purposes. There are different speeds, different storages, different sizes, and the classic Arduino Uno that everybody uses are fairly bulky. They're like the size of a credit card with chips sticking out, so they're not tiny. And you can scroll all the way down, and these are all official Arduino products, to really small ones to control LEDs, something similar to the Pro Micro that I have. They range in all sorts of different sizes. The DigiSpark is not an official Arduino product, but it still uses the same Arduino IDE that you see right here. So if we just try and move this into this particular board, it's not going to work, but really it's just a few simple steps to get it to recognize this board. Now, the other issue that's going to occur is we chose this particular Pro Micro for a really specific reason. These ones are able to pretend they are HID, human interface devices, very easily. They're designed that way. If you use something like an Arduino Uno, it's not designed that way. And the Tiny85 has some of the similar problems, but what I found is that this particular chip is very popular because it has that USB built right in to the chip right here. And so people have found ways around it, and we're going to explore how that actually happens, how we connect it to the IDE, how we build what we're trying to build. The tutorial I'm going to follow is by Thomas C. And what they've done is created a rubber ducky. Now, the rubber ducky is much more sophisticated than my mouse jiggler. My mouse jiggler just moves the mouse, maybe click a few keyboard controls. The rubber ducky is meant to enter specific keystrokes. It's supposed to take certain files, enter specific keystrokes, blah, blah, blah for perhaps hacking purposes and so on. So we're not going to go all the way to do that, but it's a very minor jump above what we're trying to do. Anyways, I'm going to stop talking and we're going to start working through, but I'm going to open this up and just work through and figure out what the steps are that we have to do to get this working. So I had a bit of problems trying to get this running, and you can see there are all sorts of weird errors that show up. And as I Google, I'm not the only one with it, but it didn't seem super common. So at first, I wanted to see if I can go into the digimouse.h file to try and fix some of these errors, but it just didn't really make sense. It seems to be that the drivers weren't installing on my computer correctly. That's basically it. And in some ways, that is not a surprise to me at all. My current desktop computer just has so many things running that conflict, that mess with the drivers, that shouldn't have surprised me. So I took a bit of a break, and instead I put it onto my Surface, which is always a good reason to have multiple computers in front of you. I followed the same steps, did the exact same things, and this runs perfect. It does exactly what you might expect it to do. And the real tip-off here is if I go to examples and I actually use the example they provide, it just wouldn't compile. It wouldn't even compile, let alone pass it on to the script. So not surprising in many ways. Anyways, what I wanted to go over is how it was working on the Surface, and most likely how you would be doing it. And it is actually quite simple. I was using this particular tutorial, but I did find another one that seemed to use almost the same steps, virtually the same steps, but was just a bit more directed. What we wanted to do was open this up, of course, and you can't really tell if I show here because I'm so tiny on the screen, but you can see that there are a number of pins. There are fewer pins than if you have an Arduino, but in theory, one of my previous projects was to connect a Bluetooth module to this so you can send keyboard and mouse commands through it, and this would just do fine as well. They come with a bunch of headers, so you can add those modules if you want. But what you had to do was first download the driver. You go on GitHub, download it, install it, click the installer. I go 64-bit. I think virtually all modern computers will be 64-bit anyways. Don't worry about this. Then you go into Arduino and add the board. You go into your preferences, add this JSON file which lists the boards, and then you go into your board manager and you install the correct packages. This automatically includes all of those DigiSpark packages. which are over here, all of the libraries. And so they do it just a little bit differently. They don't use the same keyboard module, mouse module, blah 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 blah. So you got to use all of their packages, their libraries. Once you do that, you're ready to go. The other little tiny difference that is interesting is for DigiSpark modules like this one, you're supposed to compile it first, and then it gives you a little bit of a prompt to then plug in the device. So it's not like Arduino's where you just leave it plugged in and it can write into it. You're supposed to plug in after you get that prompt. If we go through the code that I quote unquote written, but really more like adapt, I added the DigiMouse and DigiKeyboard files. These other dependencies are already in the H file, so I don't know why it came automatically. I'm gonna comment out so we get both the keyboard. We're gonna have the init, and I am gonna uncomment out all of this. So what am I gonna do? I'm gonna send a keystroke first. It's in their example project, and it seems to be this thing so that it starts it off for older systems. Not necessary. I could probably take this out. And if you remember from our previous video, we decided to do a random walk. We can certainly move one pixel up, down, left, right. But what this code does is it smooths out your random movement of the mouse. So it's never exactly perfectly up, down, left, right. There is a bit of motion, there's a bit of speed changes, and so on, so that it seems less like a mouse jiggler and more like random human movement. Okay, so what I'm going to do, and this is my setup, I'm going to move into my Surface and compile this, ready to go. So let's see if this compiles. Oh, no. DigiMouse device has no member named init. So this might not be necessary, but let's take a look at the mouse example here. It does call it. So let's copy. Call init to enumerate. Then it does a bunch of movements. There could be a bunch of button clicks. Okay. Try this. And let's try one more time. Yep, same thing. It doesn't have an init function. So I'm gonna delete this and see if it compiles without it. Uh-oh. Not compiling. Okay. I know you guys can't see this, but I'm gonna run the example DigiSpark mouse and see if it compiles. Yep. Oh, I see. In the version that is on my Surface, the command is begin instead of init. So let's hope this one works. I'll compile. Nope. What is happening here? Okay, well, if that is the case, we will just start with the example instead. So we're going to use the mouse. And I'm going to try one more thing, which is I'm going to remove that import of the keyboard because we really didn't need that. That was not the goal of the project. So maybe there's a clash between the two. I'm seeing the same error on my computer. Yep, that's precisely it. There was a conflict between the DigiMouse and the DigiKeyboard, so they might have been using the same items. Okay, completed. So what I did was remove the DigiKeyboard. I swapped this init to begin and remove this keystroke, which is not useful. Okay, and moment of truth, I'm going to plug into this computer, and what we should see is this mouse move quite randomly throughout the screen. After a delay of 2 seconds. And it is not doing that. That's very disappointing. Let's see if it does on my Surface. Oh, look at that. It's saying that the USB isn't recognized. Okay, so I guess I'll have to troubleshoot a bit, but at least it's compiling. Be right back. Okay, so I have run this code on the left on my Surface to get this running. And just to show you guys that works, watch the mouse. It is dead center, hands up, and it does take a second to start, but you can see it randomly walking around the screen now. Very robotic in how it moves, and I think just based on how this is over here, it's just going to move to the bottom left and stay there. There's no moving to the other direction in this code. Now, couple things. Unplugged it. My code from before, where I wanted a more smooth random movement, didn't work. It just kept causing this USB to crash on my Surface, and it says, something like your USB isn't functioning properly, blah, blah, blah. And I have two possible theories. Number one is that this DigiSpark has very little onboard memory, and I wonder if this code is just too long. I don't think that's likely because this is not a long piece of code, but it does make a difference between the Pro Micro and this DigiSpark chip. The other more likely reason is this little warning here, where we gotta call the DigiMouse update every 50 milliseconds. In my random walk version of this, I have a lot of your mouse stays still, because if you're working, if you're using it like a human, you are not constantly moving the mouse. You need a bit of time to wait, a bit of time to move along. I think there are different ways we can do this on this end as well. But what I'm realizing right now is that this chip, this DigiSpark chip, is really quite amazing because it's built in. It has a built-in USB port right here. That's what makes it so easy to plug in to start and get moving. It's small, it's convenient, but it's not very polished in comparison to the Arduino Pro Micro that I was using before. And what I mean by that is already earlier on we were talking about how the mouse clashes with the keyboard. You can't do two things at once. That's not great. This whole thing about keeping it alive or else it might die, That's not great. The memory that's lesser, these drivers, all of it leads me to think this is not the same experience. And so, unsurprisingly, different tools for different purposes. I have wanted something to keep my computer alive at night when something is running in the background. This is perfect for it. It'll just keep the mouse moving. Very simple code. Seems to work on my Surface. So, perfect use case for this. They're so cheap, too. I got a stack of these. I got a large stack of these from AliExpress, and they were, albeit not official DigiSpark, but just the same component. I paid a little over $10 USD for 8 of them, so they're a little over $1 each. Extremely cheap, even cheaper than the Pro Micro. But my goal and one of my future projects is to keep expanding on this to actually do things. The last project I had was sending Bluetooth commands so that I can control my computer from afar with a app, with a website, something like that. I wanted to build this into a more sophisticated Stream Deck, and we did that before in a very non-sophisticated manner. I wouldn't choose DigiSpark for it. If it crashes, if it has all sorts of problems, that's a terrible experience. But if I'm just trying to make the mouse move a little bit and keep alive, this makes a lot of sense. So, different tools, different purposes. I think the next project, I'm going to go straight back to the Pro Micro. But these ones are going to be pretty cool, so I might make a bunch of these and just hand them out to coworkers or something who want to keep their computers alive. Anyways, I hope you found this interesting. I hope to have more varied and diverse content, so I'm leaning a bit back on the Arduino products in the meantime. If you enjoyed it, let me know. Thumbs up, subscribe, like the video, leave a comment. If you didn't, also leave me a comment because it's interesting for me, but it might not be interesting for all of you. Thanks for watching. I will see you guys next week.